All right, so we've spent a little over 2 weeks looking at Chapter 5, and we've only gotten through the first half of it. We still have a couple lessons to do. Now, all of Chapter 5, since the very beginning, since Chapter 5, Lesson 1, I've said the important part is that we learn that we can't use percentages in a math problem, and that's where we are today. So we've looked at how do percentages get written as decimals, how do percentages get written as fractions, how do I change a fraction into a percentage, how do I change a decimal into a percentage, and using those numbers over and over and over again. So the true understanding of all of that working with percentages and how all of those numbers, fractions, percentages, and decimals can be the same thing, just in a different form, takes us to this lesson. This is what I have to understand. Now this lesson, it's going to be longer than the other ones because there's 2 ways that I can do every single one of these problems. And some of you, let's face it, you're better at fractions. And some of you, honestly, you're better at decimals. And I don't care which way you do it, as long as you know how to do it. And you do it well. And you can get to the right answer. So I'm going to show you every question on how to solve it both ways. So if you're really a decimal person, then take the notes on the decimal work. If you're really a fractions person, then take the notes on the fraction work. But here's the thing, you need to know how to do both. So at least the first couple, I would take the notes on both of them, especially when you get to like the last question on the front page, because you may have to be able to explain how to do both. When I look at this situation that we have here, such as 15% of 80, or 85% of 620. That is impossible mathematically to do. I can't do it. Well, let's look at some questions that might have come up over the past week. So we just got done with Thanksgiving break, right? Some of your parents are brave enough, or a little bit on the crazy side, they went out Black Friday shopping, and maybe you went along with them. I've done it 3 times in my life, and I don't ever plan on ever doing it again. That's some crazy stuff going on out there in this world. But let's say there's something that you really wanted that was about $60, but your parents found out that during Black Friday it was 70% off. How do they know if they have enough money to pay for it or not? Can you tell me what 70% off of almost $60 is? What if your item was $56.95? What's 70% off of that? Well, I don't know. But mathematically, I can't type that into a calculator either. So how in the world could I find out how much that was going to be taken off? Well, in order to do it then, I would have to know that I can change my 70% into a decimal or into a fraction. And we said when we go into fraction forms that I can put it over 100 and reduce. And when I go into decimal, I can drop my percent and move it from right to left 2 times. But still, what am I doing? Well, almost every single time you're going to see that percentage of the price or the value or the number of items that are there. And that's where we go back to the first week or 2 of school where we said of always means multiplication in this scenario. Doesn't always mean multiplication, right? We said there was 85–90% of the time that it does, but every once in a while they throw it in a different place that doesn't mean multiplication, which we get into a little later this year. But once I know that it's multiplication and I can't use that percentage, then I can put my 70 over 100, reduce it down to 7/10, or I can drop that percent sign and move it from right to left 2 times with a decimal and get 0.70, which we get rid of that 0 and it's just 0.7. Then I could use those and multiply. Well, how do I know how to multiply by a fraction? Because I taught you how to do that in chapter 1 or 2. And how do I know how to multiply by a decimal? I taught you that in around chapter 1 and 2. So we've been doing that now for almost an entire semester of school. So the math part is not difficult. It's really not difficult to set up the math problem. It's just remembering those steps. And that's what this video is to do, to help us remember how to set up those steps. So once again, I'm going to show you both ways. For the first couple, I would write down both ways. You might need that on your homework tonight. But when it comes to getting into the practice problems for the assignment, then take the ones on the way that you know you're going to do it. If you know you're going to do fractions, then you can take those notes on fractions. And if you know you're going to do percents, then you can take your notes on those percents. This says a typical family of 4 uses about 400 gallons of water each day, and 30% of that water is for outdoor activities such as gardening. How many gallons of water does a typical family of 4 use each day for outdoor activities? So the math that we're looking at is the basic information. This says to use ratio reasoning. So that goes back to chapter 1 and chapter 4 when we get into ratio reasoning. So then they set it up in this way. And some of you will look at that and think, what in the world is that even trying to tell me? I don't know what those boxes are saying. So when we step back and we look at it in a logical manner, and we can see that, well, there's out of 400 total, but this is talking about 3 groupings of something. And how many groups are there? Well, there's 10 groups, right? So we're talking 3 out of those 10 groups. And 3 out of those 10 groups would be 3/10. Or if we're talking about hundreds, then it would be the same as 30 over 100, which is 30%, right? So that's all this was showing you, is that if I look at it as a table, as a chart, as a diagram, as a graphic source, all of those fancy words that we mean for picture, I can see that, well, if I had these 3 or 30% out of the 400, then I could take my 3/10 as a fraction, and I could multiply it because it says 30% of this water. So 3/10 of 400 would give me a multiplication problem. But I can't multiply a whole number by a fraction, right? That takes us all the way back to multiplying by fractions. So I always know that I have to put that number over 1. And then I have 10 and 400. They both end with zeros. And we said the shortcut to that would just be to cross out 1 0 to where I have 1 and 40. You could multiply across, and you could get 1,200 over 10 and then have to reduce. But if I cross reduce now and I have 1 and 40, then when I multiply across, I get my 120 over 1. 120 gallons, therefore, would be my final answer. So let's look at what they're setting up here right below your picture of the boxes. So they're saying that if I know that 10% of 10% of 400 is the same thing as saying 1/10. How did I get 1/10? So we take our digits that make up our percentage, put it over 100, and then I would reduce. I would have had 10 over 100, which changes into 1/10. So they kind of skip a step there of showing work, and that's fine. We still can see where that comes from. Then when I multiply across, I would have 1 times 400, which is 400, and 10 times 1, because we know a number has to go over 1 when I'm multiplying, and that'd be 10, so that would give me 40. They're saying then, well, if I had 30%, so this is just another way of looking at it. There's several ways to look at it. If I had 30%, that would be saying, well, if I had 1/10, or 10% is 40, and this is 30, so that's 3 groups of 10%, then 3 times that 40 is going to give me what? Well, 3 times that 40 is going to give me, since I have 3 groups of the 10, is going to give me 40, 3 times 40, which is 120. Same thing we had with the boxes, right? So same answer. Well, what about down here? This says, here's another way to do it. Set it up as your 30 over 100, because we take our percentage, digits, put it over 100, and I multiply it by 400. And when I cross reduce my 100 and 400, then I know that that has to go over 1, and I could get rid of those and end up with, or multiply those, and get 12,000 over 100. Well, 12,000 over 100, there's zeros there that cancel out, right? 2 zeros and 2 zeros. So I cross those off, and now I have 120 over 1. Still 120. Holy cow, how many ways do they want us to see it? Well, there's still more ways that we can look at it. We can still look at it in this way also. We can say, well, instead of doing fractions, let's look at it as a decimal. I'm going to cross out my decimal or my percentage. I want to move my decimal from right to left 2 times. I know that gives me 0.30, but we get rid of that 0 at the end. So it's just 0.3. So I have 3/10. Of, once again, means to multiply. So I would take my 400 times my 0.3 or my 3/10. And when I multiply those together, I have 0 and 0 and 12. Well, I have 1 decimal space, don't I? Because I have to remember how to use my decimal spaces when I'm multiplying by decimals. That's key if you're going to be a decimal person on this assignment. I know I have 1 decimal space. I have to move my decimal from right to left 2 times, or excuse me, 1 time. So it gives me 120. Every single time gives us 120 gallons. Okay? So we looked at 4 different ways there that we can look at it. We're going to work all of these in 2 ways, going from a fraction and going from a percentage. So now it says try this. Find 65% of 300. So the first thing I always set in my head is of. Of means multiply, always and forever, 90% of the time. So 65% I can't use. I either have to make it a fraction or I have to make it a decimal. Which way am I going to use? I don't care. I'm going to work it both ways for you, so you have both ways. Now, on this one, I would take your notes so you know how to do it both ways. I'll tell you when you only have to take one set of your notes. So I look at my 65%. The first thing I'm going to do is I'm going to change it into a fraction. I take my digits that make up my percentage, I put it over 100, and then I reduce if I can. I can because my divisibility rules from the first week of school tells me 5 goes into 65 and 100 because it ends with 5 and 0. So when I reduce by 5s then, I can see that 5 goes into 65 13 times, and 5 goes into 120 times. So my fraction is 13/20. 13/20 of, meaning multiply. So I'm going to take my 13/20 and I'm going to multiply it by my 300. If I want to do my decimal, went a little bit too far, then all I have to do is drop my percent sign, move my decimal. My decimal's not there, right? If it's not there, then I know I put it at the end of my 2 digits, and then I'm going to move it from right to left 2 times. It's always going to go at the end behind the last number or the last digit and the percent sign, because that way if there are 3 or 4 different numbers or digits, then I know I still want to move it 2 times. So I move it 2 times, I get 0.65. So 0.65 of, meaning multiply, 300. Well, which way do we do? Well, that's up to you. So I know these are going to be my 2 options. I don't care. You tell me which one you want to have there. So for this one, once again, I would advise you to have both so you know how they both work. And maybe you can explain that on the front page of your assignment where you might have to do that. Mathematically then when I do it, I take my 13/20 times 300. We know that we have to put our whole number over 1. We did that in our multiplication of fractions early on. I cross reduce if I can. I know I can cross reduce. They both end with zeros. But 20 will go into both of them also. So 20 goes into 1, or 21 time. And if I don't know that 20 goes into 315 times, then I take my handy dandy calculator and type in 300 divided by 20 equals, and I'm going to see that it goes in 15 times. Then I'm left with multiplying across. 13 times 15 gives me 195 over 1, and I don't need that 1 because it's not a ratio and it's not a fraction. So I'm just going to say that it's 195. On my decimal point then, if I know that I have it out of 300, of means multiply, and I'm going to use 0.65. So then I'm going to have 300 times 65 hundredths, 0.65, multiplied by my 5, so I get 0, 0, and 15. My second number tells me to bring down a 0. I multiply it by my 6. I have 0, 0, and 18. When I add those together, I get a big number, much bigger than that, 19500. But we have to remember, 2 decimal spaces tell me to move my decimal point 2 times from the right to left. still is going to put it behind the 5, still is going to give me 195 as my answer. Both ways of doing it lead to the same answer, right? I don't care if you do it as a fraction, I don't care if you do it as a decimal, as long as your math is understandable, I can read it, and you get to the right answer, then you both get to the same point. Correct answer would be up here of 195. All right, here's a second example. Once again, I would show both ways just so you know how to do it. So Charlotte earns $4,000 per month. She spends 40% of her salary on rent and 15% of her salary on groceries. How much money does Charlotte have left for other expenses? So we have two different numbers. So I have to read my math problem that they're presenting me with and make sure I understand everything it's asking me to do. I have 40%, and if I just start working with my 40%, I'm going to get the wrong answer. I have to take my 40% and my 15% and put those together. Those are expenses that she has to spend. Has to be on groceries, has to be on rent. Okay? So that is a total of 55%. So what does she have left? So when we talk about percentages, we're always talking out of our whole, and our whole is always what percent? Hopefully you thought 100%, and if you weren't sure, then you looked at your paper because they show you. That's 100%. I know I have to subtract the 55% that goes out for bills. That 55% leaves us with 45% that we can use for other expenses. So how do I use 45%? Well, I can either change it into a decimal or I can change it into a fraction. So when I change it into a decimal, I drop my percent sign, I move my decimal from right to left 2 times, and I get 0.45 or 45 hundredths. If I want to do it as a fraction, then I'm going to take my 45 and put it over 100, and then I'm going to reduce if I possibly can. They both end with 5 and 0, just like before, so I know I can at least reduce by 5, and when I reduce by 5, I get 9/20ths, and that's as low as I can go. So I have both ways that I can solve it. So now I'm going to solve it both ways so that we can see that we're either going to use 0.45, 45 hundredths, or my 9/20ths, depending on which way you prefer. Once again, on this one, I would suggest that you show both things that I'm showing you. If you need extra work to show your work on, or extra paper, excuse me, to show your work on, once again, it's up here in the front of the room. So as I'm working out, then we know we have $4,000. We're going to be finding first, then, we're going to use the decimal point of 45. So 45 hundredths times 4,000. So now you could just type it into your handy-dandy calculator, but showing your work, we have 5 times 0, 0, 0, and then times 4, which is going to give me 20,000. My second number tells me to bring down a 0, and then I multiply by 4s. 0, 0, 0, 16. So that gives me 160,000. When I line those up and I add them together, then I get 180,000. However, I have 2 decimal spaces. So my 2 decimal spaces tell me to move from right to left 2 times. When I do that, then I can see that I'm actually end up with an answer of $1,800. $1,800 is her rent and her groceries together for the month. But let's say you like fractions better. Fantastic. We're going to take our 4,000 and we're going to multiply by our 9/20ths because we're talking about, once again, 45% of $4,000. So when I have this set up, then I know it has to go over 1 because I always have to put my whole number over 1 when I'm multiplying fractions. I can reduce by 20 on both of those, and if you don't see that automatically, then simply type in 4,000 divided by 20. You're going to see that 20 does go into 4,000 evenly. So now I have 9 over 1 times 200 over 1. Well, then I'm just going to multiply across. 9 times 200 gives me 1,800. My 1 times my 1 gives me a denominator of 1. I would only use that if I'm using a rate, a unit rate, or ratio, which is not the case on this problem. I'm looking for my dollar answer, which is, once again, $1,800. So either way that I solve it is going to get me to the same answer, which is my goal. It doesn't matter if I do it as a decimal. It doesn't matter if I do it as a fraction. Both directions are going to get me to the same point of $1,800. All right, so as we move forward then, here are our practice problems. You can choose from this point forward. If you know you're going to do decimals, then just show the decimal work that I show. If you know you're going to do fractions, then show the fraction work that I'm going to show. If you want to show both, it's fine. You'll run out of space, but once again, I have notebook paper up here for you. All right, so the first one says, find the percent of the quantity. Now, there are going to be times that they just give you these boxes, and you have to figure out what these boxes are saying. And if that's the case, like on NWEA, which is coming up here real soon for our second time, or the I Learned, you just have to be able to do that so we can do that. We can see that I have 320, and then it's divided into how many equal groups. 1, 2, 3, 4. 4 equal groups. And if I'm talking about percentages, then groups of 25%, right? Because 25, then halfway is 50, 75, 100. And I know that 1/4 is the same as 25%. 2/4 or 1/2 is 50%. 3/4 is 75%. All right, so we should be able to figure all that out. So let's answer these questions. 25% of 320. If 25% equals 1/4, so we're going to use how many equal groups? Well, we're going to use 4 equal groups. 1, 2, 3, 4. Then 1/4 times 320, because of means to multiply, is equal to, well, when I multiply those across, I have 1 times 320 is 320. 4 times, I have to put that over 1, gives me 4. And then when I reduce those, when I divide, my numerator goes inside my calculator or my division box. 320 divided by 4 gives me 80. So I know each of those are going to be equal to 80 points, 80 apples, 80 pencil leads. I don't care what they are because it's not actually a story problem. All right, so now we're going to go down to number 2, and I'm going to work it both ways. You can choose which way you want to show it. I don't care. As long as you know how to do both of them, then you're good to go. 80% of 50, I know I can't do it. I can never use percent in a math problem, so I have to change it. I either have to change it into a fraction or I have to change it into a decimal. Which way you choose to do it is up to you. I'm going to start with a fraction, so now I'm going to take my 80 and I'm going to put it over 100, and I don't like working with big numbers unless I have to, so I personally am going to choose to reduce it. I know this is going to reduce down to 4/5. Well, how did I get 4/5? Well, I could mark off my zeros, which gives me 8 over 10, and they're both even. So 2 will go into both of them. So then I would have 4 over 5. Or I reduce by 20, and 20 goes into 84 times, and 20 goes into 105 times. Either way, I get down to my 4/5, which is what I'm then going to use. So I substitute that in, right? Substituting, once again, we learned was just to put in the place of. So 4/5 times the 50. So 4/5 times 50, I have to put my 50 over 1 in order to do it mathematically. I can see there's a 5 here and a 50 which ends with a 0, so 5 will go into both of them. So I can reduce by 5s. 5 goes into 5 one time, and 5 goes into 50 10 times. And then I'm multiplying across with what's left. I have 4 times 10, which is 40, and 1 times 1, which is 1. It's not a ratio, it's not a unit rate, and it's not a rate. So I'm just going to leave it as a 40. So my final answer for question 20 is 40. But let's prove it. What if you want to do a decimal? So you're going to go, once again, drop your percent sign, move from right to left 2 times. Decimal always goes at the very end of my percentage if it's not already there. And I always move it 2 times, no more, no less. So I know I'm going to end up with 0.80, but I get rid of that 0 because I don't want to have to mess with it. It's just 0.8, 8 tenths. Then I have of, which tells me to multiply. I'm going to take my 50, and multiply by 0.8. Well, 8 times 0 is 0, and 8 times 5 is 40, so I end up with 400. However, I have to make sure that I have 1 decimal point, and then I move it from right to left 1 time. When I move from right to left 1 time, that tells me it's equal to 40. Same thing I got there. So yes, indeed, my answer is 40 for question 2. All right, so question 3. Question 3 says 175% of 24. Once again, the things that should be going through my thinking mind. Can't use a percent, and of means multiply. If I can't use a percent, I have to change it to a decimal, or I have to change it into a fraction. You choose which way you want to do. So here's the notes you should be taking. I'm going to give you both of them. Here's the first one. If you like fractions, we're going to start with fractions. So now this one looks a little different because it's more than a 100, but I can still do it the exact same way and keep my setup without having to work with a mixed number, and I'll explain that here in just a second. So I always take my percentage, my digits that make up my percentage, and I put it over 100. Then I see if I can reduce. Well, if I think about money, which is what I always do when I see these type of problems, I have $1 at the bottom, I have $1.75 at the top, quarters go into it. So if I reduce by quarters, I know that 4 quarters make $1, and in $1.75, that's 7 quarters. Now here's why I'm not changing that into a mixed number. Because this is a multiplication problem, right? And we learned when we did fractions and mixed numbers that I cannot multiply by a mixed number. I would have to change my 1 3/4 into 7/4. So I'm just going to leave it at the 7/4 and not worry about that it equals actually 1 3/4 as a mixed number. Once I have my 7/4 then I make my multiplication problem. So 7/4 of 24, so that means to multiply. Got to put my 24 over 1 to do it mathematically correct. And then I can see that my 4 will reduce into both of those, right? Because 4 does go into 24. It is a factor of 24. So 4 goes into 4 one time, and 4 goes into 24 6 times, because 6 times 4 is 24. Now I'm left with 7 times 6 and 1 times 1 in my denominators. Well, 7 times 6 is 42, and I need to get rid of my 1s because, once again, it's not a rate, ratio, or a unit rate. So we're saying that that answer is 42. All right, let's check it. Let's do our decimal. So our decimal is 175%. I go through my same steps. I drop my percent sign. I move my decimal from right to left 2 times. Once again, my decimal goes at the end between the last number and the percent sign if it's not already there. Always 2 times, right? That's where this one changes. So if I drop it and move it 2 times, then I end up with 1.75. Still does not change my math at all. Now, some of you will put your 1.75 at the bottom when you stack them mathematically to multiply. It doesn't matter which way you do it. I'm just a type person. I like to put the number with the most digits at the top when I multiply, because to me, it's easier to understand. Either way, it'll come up with the same answer if you do it correctly. So I start by multiplying by my 4s. 4 times 5 is 20, carry my 2. 4 times 7 is 28, plus 2 is 30, carry my 3. And 4 times 1 plus 3 is 700. If you don't believe that, since I didn't show my work, I take 175 times 4, and I'm going to get 700. My second number tells me to bring down to 0. Now I multiply by 2s. 175 times 2 is 350. I know that $1.75 and $1.75 makes $3.50, so I know it's 350. When I add those together, I get 4200, but I have 2 decimal spaces. So with my 2 decimal spaces, that tells me move my decimal point over 2 times, which gives me an answer of 42. This says 42, that says 42, so I know that my answer, 175% of 24, is 42. Now here's where understanding percentages and what they mean helps us. We have a number that's larger than the number we started with. That's correct. If I had 100% of 24, it would have to be equal to 24. If I had 200% of 24, I would have to double it, and I would get 48. So if I have 42, which is less than 200%, but more than 100%, I know mathematically sound thinking, that's got to be the right answer. All right, so then number 4 takes us to 60% of 210. Once again, I'm going to show you both ways to do it. So you choose which way you want to do it, but take notes. That way you know and you can look back on it on reference. That means you got to be focused. Yes, I've gone almost 30 minutes now explaining this, and I'm not done. So you got to stay focused with me. 60% going into a fraction. I put my digits over 100, reduce where I can. Now I could cross off my zeros, which would give me 6/10, which then I would have to reduce with 2's, which would give me 3/5. Or I could say, well, I know 20 would go into both of those. 20 goes into 63 times, and 20 goes into 105 times. The point is, 3/5 is what I'm going to use when I use the word of, and I know that that's multiplication. So I'm going to have 3/5 times 210. Now that 210 can't be left alone. Has to go over 1 in order to be able to multiply correctly. And then I notice it ends with a 5 and a 0 once again. I can reduce by a 5. So 5 goes into 5 one time. 5 goes into 210. I have no idea unless I use my handy dandy calculator. So I take 210 divided by 5 and I see 42. Now I'm left with multiplying across. So 3 times 42 gives me 126 over 1. It's not a ratio rate or unit rate, so it's just 126. Now when I go into my decimal points, so I have my same steps. I drop my percent sign, I move my decimal from right to left 2 times, and I see that I have 0.60, but I get rid of that 0, so it doesn't provide me with extra work. So I'm just going to have 0.6 as my answer. Of means to multiply. So I'm going to take my 210, I'm going to multiply by 0.6, and when I type that into my handy dandy calculator, I get 1,260. 1 decimal space tells me that I have to move my decimal 1 time from right to left. So when I do that, then I see that that's equal to 126. I got the same answer, so I know that's correct. Now none of these have labels. I don't know if they're apples, oranges, pencil leads, like I said, students, teachers, or anything else. But when I get into story problems, I have to make sure that I provide my answers for my story problems. So at the bottom then we see 5 and 6. 5 says, a jar contains 125 marbles. Given that 4% of the marbles are green, 60% of the marbles are blue, and the rest are red, how many red marbles are in the jar? So I have to do some extra work here, right? This is a multi-step math problem. The first thing I have to see is that I have 60% and I have 4%. 4% green, 60% blue. Have to put those together. Those together make 64%. I'm talking about 100% of my marbles, always 100%. So when I subtract those, I can see that the math I'm doing for the blue, well, for the red ones, is 36%. Now I can do the work. Once again, I'm going to show you both ways to do it. So my 36% as a fraction would be 36 over 100. I reduce if I possibly can, which I can. I can see that 4 would go into both of those. So 4 goes into 36 9 times, and 4 goes into 125 times. Now I can multiply, because I need to find out what 36% of 125 marbles is equal to. So 9/25 times 125, have to put my whole number over 1. I can see that the quarters will go into both of those, right? I can reduce by 1 quarter here, and then 5 quarters make up $1.25. So if I reduce by 25 and 25, I get 1 here and 5 here, and then I'm multiplying across. 9 times 5 is 45. I get rid of my 1 because it's not a ratio, rate, or unit rate. If I want to do it as a decimal, still my 36%. That part doesn't change, but how I do my work does change. I drop my percent sign, I move my decimal from right to left 2 times, so I end up with 0.36. I look at my number we're talking about 125, so I'm going to multiply 125 by my 0.36, my 3600ths. Start with my 6, and I multiply 125 by 6, I get 750. My second number tells me to bring down a 0. I multiply 125 by 3, and I see 375. When I add those together, I get, 4,500, but once again, there are 2 decimal spaces. So I have to move my decimal from right to left 2 times. That gives me 0.45. or excuse me, 45.00, which is just 45. But 45 what? Story problem, right? So I have to include that it's 45 red marbles. Okay, so I got my point for my work. I got 45, which is my other point, but my label is my third point on that question. All right, number 6. There are 32 students in Mr. Moreno's class. 62.5%. Whoa, now they're going to try to throw us off and add a decimal point to that. That doesn't matter. Ignore the fact there's a decimal point in it. 62.5% of the students are girls. How many of them are boys in the class? Now, there was a question like this on your mid-chapter checkpoint that some of you missed because they gave you information on one, but you didn't look at the other, which is what it was asking. This is asking the other. If I know that I'm talking about 100% of my students and that 62.5% of them are girls, but I want to figure out how many are boys, then I know I have to take my 100 minus 62.5. 100 minus 62.5 gives me 37.5%. That's the number that are boys in the class. Our girls are outnumbering our boys, unlike this year, which our poor girls are way outnumbered. So in our boys then, we're going to find out how many are boys by either changing it into a fraction or changing it into a decimal. You choose which way works best for you. So I put it as a fraction. Now here's where I ask that all of you pay attention, because these are going to continue to come up. They're going to come up on your test here in a couple of days, and we still aren't sure what to do with these. It's not difficult, okay? So the steps are always going to be the same. I end up with 37.5. I take my digits and I put them over 100. And the first thing that I notice is I have a decimal in the top. My numerator cannot have a decimal. The easiest way to change that is by moving my decimal one time to the right. But what does that mean mathematically? If I move my decimal one time to the right, it means I'm multiplying by 10. So if I multiply my numerator by 10, I have to multiply my denominator by 10, and therefore I have to have 375 over 1,000. There were like 2 questions like this on your mid-chapter checkpoint, and there are several of you that still have to rework those because you're still not doing that step correctly. Once I get to this point where I don't have a decimal point in my numerator, then I can reduce. When I reduce, I can see that 125 goes into both of them. And maybe you divide by 5 and see you can still divide by 5, and then you can still divide by 5. Maybe you reduce by quarters and you reduce by 25 and 25, and then you can see you can still reduce by 5. I don't care how many times you reduce it as long as you get to the right answer. 125 will go into both of them though. And that leaves me with 3/8. That's a number I can work with. So 3/8 times my 32 students, which is what we have in Mr. Moreno's class. I have to put my 32 over 1. I can see that 8 goes into 32 because I know my multiplication facts, and 8 is a factor of 32. So I'm going to reduce by 8. 8 goes into 8 once, and 8 goes into 32 4 times. Then I multiply across. I have 3 times 4, which is 12. It's not a ratio rate or unit rate, so it's just 12. Now if I want to use it as a decimal, all right, I come over here, I drop my percent sign, I move my decimal from right to left 2 times. That gives me a 3 decimal point position number. That's okay, I still do the same math. I take my number of students, which is 32, and I'm going to multiply. Notice I put the 3-digit number on top, because for me, it's easier to understand that way. If you don't want to, you don't have to. I multiply by my 2. 2 times 375 is 750. My second number tells me to bring down to 0. 3 times 375 gives me 1,125. When I add those all together, I get 12,000, excuse me. But 3 decimal spaces tell me to move my decimal point those 3 times from right to left to still give me 12. But 12 what? Should be 12 boys. That's what we're looking for. So I have my work either here or here. It's up to you which one you use. Your correct number and your correct label. Now I want to tell you, when it comes to these type of problems, I prefer to use my decimals, because a lot of times we're going to get into problems where we're working with money, and money is automatically decimals. When I try to do fractions with my money in decimals, it gets a little tricky and there's an extra step in there. But if you prefer fractions, you can still do it. It's up to you. The key to this entire lesson is combining everything we learned in those first 5 lessons that we did for over a week, almost 2 weeks. Okay? I can't do those problems. I know that of means to multiply, but I cannot use a percentage in a math problem. So once I change those to multiplication, I also have to change these either into decimals or I have to change them into fractions. So if I change it into fractions or decimals, then I can do the math. So here's your assignment. You have page 293, 2 through 11. Some of you are just skipping that bottom one even though I've been asking you to do it, and they're usually worth 2 or more points. So I wouldn't skip it if I was you. In the 294, you have all 6 for your review, 1 through 6. It is a long video. It's a lot to do, but hopefully it helps you understand exactly what you have to do to get the correct answer on your math assignment. If you have any questions, come to the back and ask for help.